Hi, my name is Benjamin Drillings, and today I'm going to be talking about my midterm project, which was meant to be doing a 4-bit binary calculator using 4 types of operations, or doing that could do 4 types of operation: an ANDing, or an ORing, adding, and subtracting. Um, and so the way that I did it was, I basically have, as you can see here, I have 7 lights set up. So those 4 blue lights represent each the output number. So it will represent, so this represents the least significant bit, and this represents the most significant bit of our output. So our output is going to be 4 bits. Now, this right here, that is going to be our 0 flag. This yellow one right here, that's our carry flag, and that green one right there is our negative flag. So I added 2 extras just so I could. Now you'll also notice that my dip switch has 5 switches. That's simply because I'm only using 1 dip switch, so I have to be able to load values in. But in order to do that, I need there to be some signifier that says, okay, this is when I will load. So essentially, it doesn't matter what position these first 4 are in until I hit that last switch, until I flip it away from ground. It will not pass that value into an unsigned int, so I can use it later. So that allows me to help set up my dip switches for my 3 inputs that I will have. My first input being my first number, second input will be my operation, and the third input will be my second number in the operation. So yeah, let's get right to it. Each of the lights go off. So this represents the first number being on. I'll just run you through it. Then I'll do a little light show, as I call it. And then the second light will show the second stage. And then the third light will show the third stage. All right, so let me just reset that and go into the code. So I used the GPIOC register. As here, I used my pull-up resistors here for my dip switches. And here is just, these are the output pins that I will need to set the lights. So PC0 to PC6 are the ones that I'm using, but I just set up PC7 as an output just to make it an even 5-5-5-5. As you can see here, I'm outputting that 4-0 to represent the first stage, and then I'm saying that while my 5th switch in my dip switch is equal to 0 or is connected to ground, that I will continue to output that red light until I switch it on, and then it will input my first 4 bits of the dip switch into this unsigned int. And so I will read those 4 bits and say, okay, I'm storing it as unsigned int A, which I will use later. It then runs through this this void function that I created down below, which is essentially just a flickering back and forth between some lights. And then I will output the yellow light to be on, or my carry light. I will do the same thing. Now this one is my operation, so you'll see this later. I'll explain. Unsigned int C, remember that. And then I do the same thing. I input my my last 4 bits to be my last number. And then I use this hold on just so that way I can keep my, that way the user has control over when the results go away. So what I did was I said, while that is still 0, I output these. Now the first one, if C equals 1, I'm going to do an AND. So if my int, remember I said to remember int C? That was because my int C was my command. So if my integer for unsigned int C is equal to 1, that means I'm doing an ANDing. All right? And the way that I did the AND was I said that if my result is 0, I will output my 0 flag. Else, I will just output that number, because unless it's a 0, you're going to get a normal number without a carry. Same thing for OR. I did, unless if it's 0, output 0. Otherwise, just output the number. Then it got a little tricky. So for addition, if it's 0, I want to output a. I said that my my integer will be ANDed with. I need to make sure that my my unsigned int carry I must be shifted to the right one, and then AND it with 1 0, and then I get this output where I add the 0 flag with the carry flag. So essentially what I'm doing is I'm saying if my integer is 0, what I want to do is if there's a carry, that carry will be in the 5th bit spot. So that carry, if I have 15 and 1, that will be in the 5th spot. But my carry flag is in this. If I were to output it, my carry flag would be in the 6th spot. So I want to move that 1 over 1. So I move it over 1 and I end it with 2. Now this is good because let's say I just added 0 and 0. That means that I will have no 1 in the 5th spot to output. So I'll just have a 0 in this spot. Therefore, all I will output, this will be equal to 0, and that will be my 0 flag. So I'll automatically just output at that 0. And then over here for this subtraction, I did a little bit of manipulation so that way I could say that I basically did the subtraction using the complements and everything, and I essentially just was trying to manipulate it so that way I could get that negative flag. That's what this is here. So that way I can get that flag to be equal to 1. I could get the negative flag to pop up. And the way that I specified it was that if A is less than E, so if my first number, which is subtracting from if my second number is greater than my first number, so if I'm doing like 1 minus 2, so if the 2 is bigger than that 1, then I will run through this, and yeah. And then otherwise I'll just output the output. All right, so let's just look at the code. I think the best thing to do would be to run through a negative and then run through a 0 carry. So let's first input a 1. All right, and I want to do a subtraction. So you see how it's running through this little light show. So I've got so my 8th option, not my 8th option. To get subtraction, I need to be able to set my I need to set my dip switches to 8, flick it on, right? And now let's do 2, just to make it simple. All right, so that's a 2. I'll implement it. And there you go. My green flag is on, that's my negative, and a 1 is on. So 1 minus 2 is negative 1. Perfect. Now normally it'll run through a whole cycle, but I want to keep this video short, so I'm just going to reset it. Now let's do work with an add with a carry. So add with a carry and a 0, just to show you that it works, because it's a pretty interesting thing that it took a lot to actually get it to work. So there's that, and now my adding is going to be 4. So let's move that there. So see, 4 is up. So I'm going to pass that. I'm just going to add a 1, because 15 and 1 is 16. And so that means my 4 bits will be 0. And look at that. My 0 flag, which is the red, and my carry flag, which is the yellow, are both on because it's my answer is 16. But because my answer is 16, all of these are going to be off because I have nothing being output. I can show you when all the lights come on, I believe. It would be highly disappointing if they didn't come on. So let's just say I want to do 3. I want to add 7 and 8 just to get 15. So I'm gonna do that. Gonna move those 2 up. Oh, it skipped a bit. Wait a second. Messed it up. So let's just do that. Boom. I want to do 4. See, only the 4 is up. It's difficult to do this while watching the camera. Oop, the resistor kind of got a little fukakied. Yeah, believe, then I just want to do this right here. And boom, there, all 4 lights go up. So that is a visual representation of everything. I can run through, you know, the ANDing and ORing were pretty simple. I just wanted to run through the adding and subtracting because they were a little wacky. I can just show you really quick the ANDing and the ORing. So I do 1, and then I do 1, and I do 1. So what that's going to do is it's going to do, I'm not looking right now, it's going to do an ANDing right now of 1 and 1, which gives me a 1, right? And so let's say I want to do an OR really quick. So I'm going to do an OR of just 0 and 0 to show you that nothing comes up. So, or actually I'll do an ORing of 0 and another number, just so you see that another number comes up. It's pulled out. So I'm doing that OR, which is the 2. And I'll do 3, just to make it simple for the dip switches. So I'm ORing 0 and 3. So what should come out is 3. Perfect. See? So that's it for this video. I hope this was explanatory. I hope this was helpful. I hope I included enough stuff. And yeah, I hope this was informative. So thank you for watching, and stay tuned because next week we'll be doing the LCD lab, and I'll talk more about that later. Thanks for watching.